Okay, so good afternoon, everybody. Okay, so before we start the new chapters, let's see the homework solution. So first homework is about the word versus growth, and then they gave us print out the results already. So first question, based on these estimates, interpret the result. So, okay, first you have to see r square. So r square equal this one, which means 34.75% of the data fit the model. Then you have to interpret the coefficient, which equal 0.65, which probability is less than 0.01, indicate that if growth increase by 1, but the unit here is growth rate. Okay, so 1%. If the GDP growth increase by 1%, the vote, which means the percentage share of popular vote won by incumbent party. So percent share X percent share increase by 0.65. Okay, significantly. Okay, so this is the keyword significant at 1% significant level. Significant level. Okay, so this is the keyword that you have to write when you have to interpret the result. Second question, if growth rate is 5%, what is the predicted value of growth? Okay, so the second question, you can use 5 by growth at equal constant term plus slope, and you can use 5% here. And you will get 51.72, which means if the growth rate is 5%, they will get 51.72% of vote. 3. What value of growth would have led to a prediction that incumbent party or Republicans would have won 50.1 of the vote? So instead of fill the vote, you fill the vote to equal 50.1 equal 51.69 plus 0.65 and growth Then you can solve for the growth. So growth will equal 50.1 minus 50.69 over 0.65. And you will get minus 43, yeah? Around this, yeah, 2.43 to 5.4. This means it indicates that if the GDP growth is negative, right? Uh, but it's not if it's not exceeds minus 2.43%, still this party will win the election. Okay, so this is number 3. And the number 4 test at 5% significance level. The now hypothesis that economic growth has no effects on percentage vote earned by the party. Explain your choice. So H now H1. So no effect, which means if this value equal 0, this means no effects. Okay. Versus, yeah, it's affect, yeah, sure. It's affect word. Either is positive or the negative impact, no matter, just have impact. So it's become two-tail test. Uh-huh. Then the second step, you have to compute here, which the program compute for you already. So second step, E equals 4.06. Third step, typically you have to open t-table, but if you have print out, you can read the probability. So prop t, yeah. Oh, yes, at 5%. So since prop 3 less or equal than 0.05, um, we oh, we reject H now, then beta to not equals 0 at 5% significant level. Or economics growth has effect on vote. Okay, I use this sentence to rewrite again. Oh, my bad. I rewrite this sentence to make sure that I understand the question. Okay, so the answer is it has effects. Since the pop is less than 0.05, show that it has effect. Okay, so second question. Homework 3.2, I gave you three model. Okay, if you use evil, you can reproduce the same without as a question. So first question, which equation do you think is preferable? Why? So to consider which model is better, we use R square, which means which one is better fit the data. Okay, and then this printout have the highest R square among three model, which means is yeah, yeah, thank you. So we prefer printout three, right? Printout three because they have the highest R square, the best fit model. Then the second question, interpret your preferred result. Okay, so R square equal 0.5685, which means 56.85% of data fit the model. Then beta 2 hat. Okay, I will write somewhere here. Beta is gamma, right? Gamma hat 2 equal 0.003, which probability is less than 0.01. Indicate that if time square increase by 1, Chapman or Y, which means yield, okay, you increase 0.0000355. Okay, significant at 1% level. Okay, so if time square is positive, okay, if you use square and it's positive, it means your figure is parabola, okay, if your beta is square. But if it's negative, it means it will be a inverse parabola, inverse U shape here like this. Okay, so it depends on the coefficient here. If it's positive, your figure is become like this. Which they have the proper economic theory is called increasing return. But if it's negative, it says decreasing return. Okay, before we start a new chapter, how about if I would like to interpret the second one? This is called linear log, right? So linear log, you have to interpret as time increase. They have log, right? So 1%, yeah, y positive. So increase 0.185, but you have to divide it by 100. Okay. Then I will quickly review what we have learned so far before we start a new chapter. The multiple regression model. So multiple means we allow to have more than one x, more than one explanatory variables. Okay, so from simple we have one x, right? So multiple we have more than one explanatory variable. In brief is x. Okay, so quickly review what we have learned. What have we learned so far? Okay, so we start from have the data, right? We have two data, and then we would like to see the relationship between those two variables. Then we plot the scatter to see the relationship. Oh, someone had the relationship, so we use econometrics technique called OLS to find the equation. So y hat equal beta 1 hat plus beta 2 hat x. Okay, and then we know from Gauss-Markov rule, Gauss-Markov theorem, okay. So Gauss-Markov theorem, they have 6 rules. First, model is correct. Second, expected error 0. Variance error constant. Covariance error 0. 5x is non-random. And number 6, error is normal distribution with expected to be 0 and constant variance. Then Gauss-Markov theorem said that if all of the rules is followed, 1, 2, 5 is followed, OLS is blue. Blue means the best linear unbiased estimator. Why is best? Because you have mean variance. Mean variance. Mean sigma error hat square. Okay, so from OLS, we can find beta hat, we can find standard error of beta hat, and we can find R squared. This is the latest chapter last week. Can find R squared. Okay, then beta and standard error together, we can do confidence interval, and we can do hypothesis testing. And hypothesis testing, we have four steps, right? Four steps. Four steps. So first you have S, oh, now H1. Second, you have to calculate. The step you have to open the table. And step C, before you make a conclusion. And then another important topic is the model interpretation. Okay, so I gave you four type of model. So linear, log, linear log, and log linear. Okay, so you have to know the interpretation. Okay, so this is what we have learned through first four chapter, and then this one we have only one x on the right hand side, right? So what if we have more than one explanatory variable? Yes, it will become more complicated and have more problem. So multiple regression model. Suppose we would like to predict the cell depends on price. Of course, if we set the price to be higher, our cell will decrease. Then we have one more explanatory variable. Instead of cell only depends on price, they said, oh, it depends on the price that we set and the money that we put it on advertisement. Okay, sales depends on price and advertisement. Then to interpret better, better to the change in monthly sale when the price is increased by 1 unit. Okay, and advertising is held constant. So underline is held constant. This is the thing that you have to write when you face multiple regression. Again, to interpret beta tree is mean the change in monthly sales when advertising expenditure is increased by 1 unit and price is held constant. So if we plot the data instead of have y and x, we have the 3D data here. So let's imagine that is 3D and we have those kind of data. Okay, so then we would like to estimate this model. Then they gather the data and get the monthly sale price advertising. This is the company name, Andy Burger Bar. Okay, so they collect the data of 75 cities and sales in each city, the price set in each city, and the money on advertisement in each city. So, can you answer me the question? What type of data they collect? I have choice: cross section, time series, or panel. This one. This is the data by city. Okay, I have choice: cross section, time series. Which one? You can guess. Cross section. Yes. So if we collect the data at one time, okay, we have several branch of data. So we get 75 branch from each city, 25 city. So this type of data we call cross section. What if we collect in time series? It means you have the data back in the old day. For example, we have only one branch, but we collect the data every month from January, February, March, so on. If this one, we will call it time series. Okay. So you have to distinguish between cross section data and time series data because it means you face the different type of data and you have to deal with it. So this one is called cross section. So we can have many X as you want. Okay. Example here we have only two X, right? Price and advertise. But the general model allow you to have many X as you would like. Then the interpretation so is similar to simple regression. So you can interpret like simple linear model, but you have to put other XL constant. Okay, let's see. Okay, we will later give you the example how to interpret multiple regression model. But let's see the Gauss-Markov theorem first. Okay, So for previous slide, I write down that in case of simple regression, we have 6 rules, right? Again, for multiple regression, we have 6 rules as well. Okay, so all the rules are the same. The model is correct, expected error 0, value is constant, no covariance between error, X is non-random. Okay, the thing that we have more rule we call no exact linear relationships of explanatory variables. Okay, so the technical term they call exact collinearity. This red text is what that difference between simple and multiple regression because we allow to have more than one x here. So we have to have the assumption that we don't have exact linear relationship between explanatory variables. I will tell you later why we can't have exact collinearity and it affects a lot to your model. Okay, so let's see the model result. After they collect the cross-section data, they estimate and get this result. So this result means cell equal 118.91 minus 7.9 price plus 1.86 advertisement. Okay, so let's interpret this result together. First, we got R squared. So R squared is, yeah, is mean. Yeah, yeah, good. Of the data fit the model. Then, beta hat to equal minus 7.9 here, which probability is, yeah, good. So this means if price increase by 1 and the unit is dollar, okay? If it increase by $1, the sale will decrease, yes, it's minus, so decrease by 7.9 in the unit of 1,000. Okay, so it depends on the question. If the question said it depends on the data actually. So if data is $1,000, it means 7.9 in terms of $1,000 or $7,900, right? If the price set by the company is increased by $1, the sale decreased by $7,900 significantly. Yeah, good. And yeah, at 1% significant level. And then the thing that you have to add in the sentence because we have two variables here. So you have to write down that the x, okay, this one, the x L constant, the x L constant, which means we have to interpret as advertisement here is constant. If advertisement is constant, then we increase the price by $1. The sale decrease $7,900, significant at 1%, significant low. Okay, so this is what you have to add in your sentence. Okay, one more time. How about 1.86 here? The 1.86 here means beta 3 hat equal 1.86, which the probability here is less than 0.01. It means if advertisement increase by 1,000, then sale will increase 1.86 in terms of dollar. So good dollar. And you have to write down that it's significant. Oh, I don't have space here. Okay, significant at at 1% level. Yes, you can write down significantly at 1% level, significant at 1% level, or significant at 99% confident. Of course, any word. And then you also have to write down that significant at 1% level, other x L constant. Question. Suppose we are interested in predicting sales revenue for a price of $5.5 and advertising expenditure of $1,200. So we, from the equation, we replace the price to be 5.5 and advertise 1.2. Why? Why 1.2? Why? Why? Yeah, because the unit here is 1,000. Okay, so if you would like 1,200, you have to say, oh, 1,200 is 1.2 in terms of 1,000 units. Yeah, good. Okay, and then you get the result equal 77.656 in terms of $1,000. Indicate that if the price is 5.5 and advertisement expenditure is 1,200, we predict the sale to equal 77,000, right? And 600 something dollar. Because the unit is 1,000. That's why you have to multiply it 1,000 and get this number. Okay. Moreover, since the price is negative, right? Minus negative, which means if we set the price down, the sales will increase. Okay, this is the like a law of demand, right? We set the price to decrease, sale will increase. Then shall we? Okay, so this is the next slide. Remark: a minus sign in front of the price means the more we lower the price, the higher our sales. Mhm. If so, that mean we should lower the price until it equals zero? Because the model says so. Why? We set the price zero and our sale will increase. Okay, so it can be seen that the model is not always correct. Because if the price is zero, it means, yeah, because it's like oh, please take it free, right? So the income will stay low. Uh-huh. So it's become the remark that regression models describe the relationship between the economic variables for values similar to those found in the sample data. Okay, so extrapolating the results to extreme values is not a good idea. Predicting the value of dependent variable of the x bar for the sample's values invites disaster. This is a disaster. Like don't do that. Okay. Okay. So this is multiple regression, and what is the difference between multiple regression and simple regression that we have learned previously? First of all, the difference is interpretation. You have to add other exhale constant. Second, the variance formula. In case of simple linear regression, variance of error equal this one equal sigma error square over n minus 2. In fact, 2 is from number of parameters. What does this mean? This means we have y equal beta 1 plus beta 2 x here. So parameter is beta 1, 2. This is the root of the formula. So multiple regression has the same formula of variance error, but we change it to be n minus k. Y k is number of parameters. And we call n minus k as degree of freedom. For example, for previous model, okay, for previous model, we have SSE here, and then we have to count K. So 1, 2, 3, K equal 3. So N 75 minus 3. then we get the variance of error. Okay, so K, you can know the K by count the beta. Okay, you can count beta. And then after you can calculate the variance of error, you use that variance of error to calculate variance of beta. Okay, I will show you that from the simple case, the variance of beta equal this one over this one. In case of simple linear regression, which means for multiple linear regression, we have 1 minus correlation. Correlation. Okay, this one is what different from simple case. We have this term in our formula, and I will show you if your two data is like this means correlation is 1. But if your data is like this, your correlation is minus 1. And then what happens if correlation is 1, okay, or minus 1, which means if correlation is 1 or minus 1, the term here 1 minus, right? So here will become 1 in both cases, right? 1 square is 1 minus 1 square also 1, so 1 minus 1 0. So it means variance of beta equal variance of error over 0. This means you will face the dy by 0. The model cannot find the answer. So this problem, we call it exact collinearity. Okay, so if we face exact collinearity, model cannot find the answer. That's why the assumption in the slide number 7, okay, let's go back to number 7. That's why the text in red, they have the assumption that no exact linear relationship of the other explanatory variables of exact collinearity. I will show you some example to make it clearer understand. Suppose I would like to know salary. It depends on experience. Yes, of course, the more experience, the higher salary. And yes, I observe that the people who are elder, they get higher salary as well. So depends on age. Yeah, this is my model. Salary depends on experience and age. And then I collect the data. Expert age. Okay, so first person, they 30, it means they have worked for 8 years. Second, 40, they work for 18 years. 50, 28 years. Because after they graduate at 22, they work after that. So the experience, they gain the same number as age. If they work 1 year more, they older 1 year more as well, right? Because they always work. In this case, if you plot age and experience, okay, so it means the higher experience, the higher age. And you may face that the correlation is 1, which means this model you will face exact collinearity. And you will end up that the model cannot find the answer. Okay, divide by 0. Yeah. Okay. More example. Maybe some people would like to. Okay, so expenditure depends on age and year of birth. Oh, this is genius. Okay, so they collect the data again, age, year of birth. Okay, so they born in 2000, which means now 24. Second, they born in 2001, they're now 23, 22. If you plot between age and year of birth, okay, you will get that the higher year of birth, the lesser age. So you face similar to this, okay? Yes, so in this case, you get -1 of correlation, which means again you face the exact collinearity problem. Yes, it's become dy by zero, and the model cannot find the answer, of course. So be careful in the future when you have to do your own work, when you select what you would like to include in the model. So please beware this problem. Okay. Then the variance and covariance of this square depends on first the variance, second sample size, third variation of explanatory variable, and fourth correlation between x2 and x3. So all four is the explanation of this formula. So do not serious about this. Next is interval estimation. Luckily, same, same as simple case. Okay, so to find interval estimation, you have to see critical value of t, and then you use beta hat and standard error. Then next, R square. Luckily, same, same as simple. Okay, so you can compute R square by SSR over SST or 1 minus SSE over SST. And the interpretation is the same as simple linear model. It means 44.83% of data fit the model. Yeah. However, be careful in the future if the model does not contain an intercept parameters, then the measure of R squared is no longer appropriate because SSE will not equal SSR plus SSE. Okay, so to conclude that it means intercept. Okay, this is this is the thing that a lot of my students come to ask me. If intercept not significant, if intercept not significant, a lot of students come to me. John, intercept is not significant. Can we throw them out? Okay. If we throw them out, R square will invalid. We can use that R square. So typically, if intercept is not significant, we still keep it. Unless the theory say that we don't need it. Okay? The case, the only case that we throw the intercept out is theory. So theory said is don't have intercept here. Okay, but typical situation, we always keep intercept. No matter it's significant or not significant, we keep intercept. Okay, so R squared is the same, confidence interval is the same, and hypothesis testing the same. Lucky. Okay, so let's try to do four steps of hypothesis together before we get some break. Okay, so from this equation, please test the hypothesis that beta 3 greater than 1. Beta 3, so 1, 2, 3 here. So beta 3 greater than 1 is H now or H1? H now or H1? H1 because because H now must have equal sign. Can you still remember this one? So beta 3 greater than 1, no equal sign. So it must go to H1. Okay, so beta 3 greater than 1 in H1. No equal. Then you pair it with H now, which means beta less or equal 1. Okay, you have to keep remember this one because you will use it a lot in the future when you have to set the hypothesis. Then t test t equal beta hat minus what you concern over standard error, which means 1.86 minus 1 over the standard error. Yeah, so get 1.258. Third step, critical value, but they gave you already. So T critical value is 1.99. Then to make the conclusion, draw the normal distribution. And then the critical value is on the left or on the right? On the left or on the right? On the right because it depends on H1. So it's greater is on the right. But if it left, it means it's less than. So this case is greater than on the right. 1.99. Then H now H1. Okay, and your calculation is here 1.258, which means you reject or not reject. Not reject. not reject H now. So indicate that they would like to test beta 3 greater than 1. Beta 3 greater than 1 is not true. Okay, so uh, hypothesis testing will be in midterm exam. So please review and make sure that you understand it clearly the four step, how to set H now H1, how to find the critical value, okay? Okay, so I think we need to take some break here. Okay, so we will back on 3 p.m. Okay, so let's break and refresh your brain. Okay, well, so hopefully you refresh from the first part of this chapter because the second part of this chapter will become more difficult. Okay, so have polynomial equations. Since we can have more than one explanatory variable, it means you can do polynomial equations. Okay, for example, ไม่รู้เมาส์มันค้างหรอ For example, in microeconomic theory, they would like you to do something like marginal product, marginal cost, something like that. And then they would like you to find uh, minimum expenditure, maximize profit, something like that, minimize cost, max profit. To do so, you have to do a polynomial equation. Okay, so for example, if you would like to know the questions similar to this, if we put linear regression, it means increased advertisement will always lead to more sales. And then if we do like that, it means you can increase advertisement forever, right? Because previously we did a linear, right? We did a linear. So this positive, if we put the money 1,000 on it, the sale will increase 1.86, which means we can increase advertisement forever. 1 million, 10 million, 10 billion. The sales still increase. You may say, oh, professor, it's not true. So to do that, we use adverse square. We put more variable adverse square. Then to interpret the model, the effect of adverse on sale, you have to do first order. Okay, this is a calculus. So curl sale by curl adverse is mean beta 3 adverse, something like this, right? So something like this. So it's become beta 3 plus 2 beta 4 adverse. And in economic theory, they use this word. This is the marginal effect of advertising on sale. Okay, so if beta 4 less than 0, it means we face something called diminishing marginal effect. Okay, so if beta is negative, it means the higher advertisement, the higher sale, but it have the diminishing effect. Then finally we can find some maximum here. Okay, so this is called diminishing marginal effect. Sale will increase after advertisement increase, but for some certain level. Okay, then they estimate and get negative adverse square. So which means they face diminishing marginal effect loop. Then more problem is that if I would like to test whether advertisement have effect on sale or not. But this time we have to adverse here, right? Adverse and adverse square, which means I have to test two variables together. If adverse has no effect on sales, mean both beta 3 and beta 4 must be 0. Again, if I would like to know that all adverse has no effect on sales, which means if beta 3 and beta 4 both are 0, adverse will not affect on sales. Versus no, at least one beta is not equal 0. Okay, you can write at least one beta is not 0, or you can write beta 3 not equal beta 4 not equal 0. Or you can write that H now is not 3. Okay, previously we use t-test, right? So t-test can test only one beta. In this case, we have more than one beta. We have to use the new test called f-test. This is the formula of f-test. Okay, so f-test, you have to know the value of sum square error SSE. And they have the word of restricted regression and unrestricted regression. What does it mean? It means sale depends on price and advertisement. And then we try to restrict that beta 3 and beta 4 must equal to 0. Okay, so both are zeros. Tum, tum. you your equation become sale depends on only price. So the equation that we force beta 3 and beta 4 to equal 0, we call it restricted regression. And the one which are longer, we call it unrestricted regression. U. So to perform F-test, we use SSER minus SSEU over SSEU and adjust by J over N minus K. J is number of restricted. For example, we restrict beta 3 equals 0. We restrict beta 4 equals 0. So 1, 2. So J equal 2. N is number of observation, no problem. K is number of beta. So you count beta of unrestricted regression, the longer one. And then this is the second step. Okay, so you set the hypothesis, you find the F test. The third step, you have to open F table. So F table, they have two degree of freedom. They have the upper one and the lower one, J and N minus K. So let's see slide number 20. This is F table. Okay, to draw F distribution, you have to draw it very positively skewed. Okay, something is very left. Okay, and the right is very flat. So this is called positively skewed. And then they have two degree of freedom. The upper one, the V1, and the lower one, V2. For example, if I would like to find F to 20, 95%. So you have to go to table 95 percentile of F distribution. Then to 20, you get 3.49. Next, F 160, you get 4. Okay. Then F only have one critical value. Okay, so this is F here, and this is become H now. This is H1. Okay, after you find critical value, put it here. If it's on the left, H now. Is on the right, H1. Only one case. Okay, then you now understand how to find all the value. So this is the step. First step, set the hypothesis. So H now always have equal sign. Okay. Then if test, you can test more than one beta together, but you can test only equal or not equal. Okay, so H now beta 3 equal beta 4 equal 0 versus no beta 3 not equal beta 4 not equal 0 or at least one beta is not 0. Okay, you can write down or at least one. Yeah, yeah, is not 0. Then second step, use F test. Okay, so you have to have two regression, get SSE of two regression and find F. Third step, find critical value. Proof H now H1. Then make a conclusion, not reject or reject H naught. Okay, so let's see the example. Example, they would like to know whether adverse affect cell or not. So they set beta 3 equal to beta 4 equal to 0. So this is the longer equation. So we call it unlisted, which this one is less strict. And the difference between unlisted and listed is therefore beta 3 equal to 0, beta 4 equal to 0. So we know that J equal to. Moreover, we can count for beta 1, 2, 3, 4. So K is 4. Okay. K is number of beta. Then finally, you gather all the information. Then you can compute F step equal 8.44. Then the third step, you have to open F table. Then you get 3.126. Draw the positive rescue critical value 3.126 H now H1 and then your calculation is greater than the critical value. Then you conclude that you reject H naught, which means at least one beta is not 0. Okay, if one beta is not 0, it means adverse has an effect on cells. Okay, this is the typical F test. Okay, so in evil, okay, in evil, we call it wall test. We will do it together after we finish the theory part. But the one that we widely use In model, we call overall F test, okay? Overall F test, which means whether your linear regression model provides a better fit to the data than a model that contains only intercept, no independent variables. Which means if you did the model, if you did forecast the model, then you would like to know, is this model valid or not? Then you set your model as unrestricted regression versus, okay, all explanatory variable. They are all zero, no effect on what? Very bad variable. Then your equation become only intercept. Okay, only intercept. Then I call it restricted regression, which in this case SSER, SSE of restricted regression. Okay, your equation become like this. Yeah. Beta 1 equal y bar because we have no x here. Okay, so which means SSER will equal SST. To sum up, the overall F test formula will become F equal SST minus SSE over SSE. J is K minus 1 because we leave intercept in the equation. That's why we have to minus 1. Then allocate. Okay. Okay, so fourth step, again, sales depends on price and advertisement. We would like to do overall F10, which means if we set both beta equal to 0, it means price and advertisement together are not affect sales, right? Because you set beta to 0, beta to is 0. Price and advertisement has no effect on sale, which means model, the model is not good because we try to predict that sales depends on price and advertisement or not. But if both are not affect sales, your model is pretty bad. Versus at least one beta is not zero. Then second step, you calculate F equal 29. Third step, you open F table 3.12. And then last step, you draw very positive this skew 3.12 H now S0, your calculation here. Then you reject the null hypothesis and conclude that lies or advertising or both have an influence on sales. And again, you may curious, oh, professor, do we have to do calculate, do F table open in real life? No. Okay. In fact, when we deal with the real data, they represent the number already. Okay. Here, the printout. Okay. So this is overall F test. Overall F test. And they provide you the probability already. Okay, so the probability say that at 95%, yeah, if it's greater than 0.05, okay, so this model is bad, and less than 0.05, so your model is passed in the first step. What does it mean? Okay, it means when you do the model, when you use the data and try to use model, okay, and then you click on your program and get similar printout. First step, when you have to interpret the printout, first step, you have to see plot F first. That means the overall, the performance of overall model. Okay, so plot F less equal 0.05, which means this model can be used to explain dependent variable cells. Vice versa, if log greater than 0.05, it means this model is invalid. You can throw this model, boom, to the bin. Okay, but since it passed, the block F must be less than 0.05 at first glance, which means this model we use lies and adverse together can use can be used to explain cells. Okay, second step, you have to interpret R squared. Okay, we know that it can be used to explain cell, but we would like to know how good of your model. So R squared equal 0.5082, which means 50.82% of data fit model. Okay. So the first step of F is like overall the model, your model is okay. Second, oh, it's good like it can explain well by 50% something. And then third step, you interpret top T one by one. For example, beta go to hat equal minus something which log E less than 0.01 indicate that the price increased by $1, sales increased by sales decreased by 7.64 $1,000. Okay, significant, my bad, significant. Significant at 1% the vote. Then you do not forget to write that other XL constant. If you can answer all of this, 2 marks, 2 points. Okay, so after I give you printouts, it is similar to the exam. I may give you printouts and ask you, please interpret the result. This means you have to, okay, first, what f is less than 0.05, so this model is valid, or this model can be used to explain cells. Second, if we see r squared equals 0.5082, it means it can explain well 50.82%. And then if we see each beta and probability, we can see that price increased by $1, sale decreased 7.64 in $1,000, significant at one level after exhale constant. Okay, we have to do other beta as well. Oh, I hate this color. Beta 3 equal above. Okay, again the block E1, which means advertisement increased by 1,000, sale increased by, okay, 1,000, significant at, yeah, good. Yes, other exhale constant. Enter exhale constant. And then this is how you write down beta at 4. So this is square, right? So to interpret the square, let's see that is positive or negative. Okay, this is negative, right? Okay. So since this negative, we call it base diminishing. Okay, because it's minus, right? You have to say base diminishing marginal effect of advertisement on sale. Okay, you can write that Advertisement square increased by 1, sale decreased by 2.76, significant at 1% level at the FQ constant, and you bracket diminishing marginal effect. That's the keyword. Okay, so when you face the question in the exam and in the future, especially when you have to write the report. Okay, so if question asks you to interpret the result, then you have to write F, right? You have to write F first. Second step, you write down the R square. Third step, you have to write down each T. Okay, to get my exam correctly, to do my exam correctly. When I have you, when I need you to interpret the result, do those 3 steps properly. Which one? No, just like this. Okay, just first of F overall model can be used to explain sales. You may add the word overall. Okay, overall, because this is overall F test. You must interpret overall F test first. For example, if overall F test is greater than 0.05, it means overall the model, oops, sorry, overall the model cannot be used to explain dependence variable, so sales. Which means in real life, when you work with data, you must see plot F first. And if the overall model is not valid, this means it's greater than 0.05, you don't have to interpret further. Do not say R square, do not do T, because first step is not passed, right? If it's greater than 0.05, it means you can throw this model, and throw it to the bin. This model is not so good. Okay. Okay, let's practice in the program together. Okay, so I provide you this data. So please use loan small. Loan small. They contain a subset of 500 observations. And then they would like you to estimate this equation. Okay, so this is the budget share depends on total expenditure, depends on age. And NK, what does it mean? NK, number of children. Okay, number of children. Okay, let's see the data together. Let's see the data together. Loan small, loan small. Okay, so The bill is like the budget share. Okay, the bill is budget share. For example, if you would like to know how many percentage people use the money on food, so is it the bill food? This means the percentage of money that used for food. And then they would like you to do any budget share depends on beta 1 plus beta 2 log total expenditure beta 3 is and beta 4 student number of students. Okay, since you have learned how to make equation already, what should I do? What should I click first? Object, yes, good. Object, new object, equation. Okay, object, new object, equation, and you name it EQ01, equation 1. Okay, then to do it, you have to put equation estimation. So the bill food, the bill food depends on constant term C. Okay, you have to the bill food depends on depends on depends on constant term, depends on log total expenditure, depends on age, depends on NK. Okay, so you have to do the bill food, the log DOT EXP. Okay, so you have to write log to become log. Okay, so this we must write down as log. H N K. Sorry? Oh no, you put error. Error is become automatic. Can you download it? Okay. Let me see. I will help you. Yeah, double click it. Yeah. Okay. Object, new object. Okay. Name the equation. Good. Oh, it's very small, right? You can't see on the top. I write the red one. So the bill food. I don't know how to make it bigger. Let's try. I can do that. I don't know why. So I will write it in the notepad instead. Okay, this is okay for you. Okay, better. Hope it's better, huh? But you have to write down the bill food depends on constant, log total expenditure, age, number of children. What happened? Keyboard is gone. Oh, yes, this gone. Okay. Oh, this computer is dangerous. Don't know why. No. Uh, on the weekday, I will have exam using the computer. This means my students have to use computer. And then there was a problem every semester that computer is not so good. Yeah, yeah, you use this. Okay, then click OK, then see the result. Okay, what did you get? The same? Okay, so after you get the result, how to read, the printout, what should you read first? Pop F, yes. So after you click OK, you get the printout, see pop F first. So pop F less equal 0.05, which means overall model is okay, right? Yeah, yes, this is what you have to write in the exam. But general idea is overall, okay, overall, this is general idea. Overall model is okay. This is a general idea. But if you would like to write the report, this is not the good vocabulary, right? You have to use, oh, this model can be used to explain the weight share of food or something like that. But this is the general idea, like, okay, overall model is okay. But if it's not less than 0.05, you can throw this model. This model is bad, something like that. Then you move to the R square, 0.26. Not so high, not so bad, because 26.82% of data fits the model. Okay, so not so good, right? Just 26%. Yeah, not so good. Very low number. But that's okay because overall model is okay. Not good for forecasting, but good for explain something. Then you can interpret each probability, right? Okay, so log is good one. So beta 2 hat equal minus. Okay, publish. Okay, and log. Yeah, you have to if total expenditure. Ah, total expenditure increased by one what unit 1 billion 1%. Yeah, log you have to know is log is become percent automatically. The bill would decrease 0.14, but over 100. Good. Okay. And significantly at 1% significance level. And moreover, after exhale constant. This is the full sentence. Okay. Then it means if total expenditure is increased, your you if you put it the share of food, it means if you have more expenditure, you reduce the share of food, okay? Because you may cannot eat anymore, right? You have higher money, you have more money, but you still eat the same amount of food. This means the share of the food of total expenditure is lesser than before. So this is a negative. Okay, just economics theory. So how about age? Age is positive, which significant. This means if, yeah, okay, good. I just the increase by 1 year. The bill would increase 0.002 significantly at 1% significant level at the scale constant. Okay, let's do one more model and we will move to B. Okay, so one more model. This is the expenditure of food. How about if I would like to know the expenditure on alcohol? Yes. So we will redo the equation again. Okay, so go to object, new object, equation number 2 equal 0 Okay, so instead of the bill food, this time I would like you to use the bill alcohol. I would like to know that how people drink alcohol depends on their age, total expenditure, and number of children. Okay, so you can view alcohol, see log total expenditure, age, and K. Okay, so after you have done it, please click OK. And this is the result. Very similar. But after you get the result, what should you do first? What should you do first? You have to see of F again. That's you have to do it automatically. So of F less than 0.05, which means the first step is okay. Overall, okay. Okay. Then R square equals 0.08, even worse, even worse than previous model, right? It means only 8% of data with the model. Not so good, very bad. 8% only. Why, right? With the model. But overall, it's okay. So why not? Then log expenditure, no problem. Significant is significant. I would like you to interpret NK. Okay, so I skip beta 2, beta 3, so beta at 4 equal minus 4. Okay, which plot? Ah, 5, because 0.01. 5, right? You cannot say is less than 0.01, right? Because they have 5 here. So you have to say that in this case is 0.05. Very good, very good. Good try. Okay, this means if the number of children increase by 1, they will drink alcohol less, right? This is the alcohol. 0.01 for significant at 5% level. Yeah, good. Other X L constant. This means if you have more kids, you drink less alcohol, which is makes sense, right? Really makes sense. If you have more kids, you have less time to drink alcohol. That's why the result is negative. Okay, so next is question B. Question B said that commodities are regarded as luxury if beta to greater than zero and necessity if beta to less than zero. Please test H naught beta to less or equal zero versus H1 beta to greater than zero and comments on the outcome. Okay, so from this equation, they would like to check this coefficient beta 2. Okay, so H now H1. So beta 1 beta 2 is greater than 0 versus no beta 2 is not greater than 0. Okay, and if you have to do, you may have to compute T, open T table, and then make a conclusion, right? But we will do it using EVIL. Okay, we will do it using EVIL. So from this printout, EQ 0 to low, let's click on view and see the coefficient diagnostic and click on wow test, wow test. Okay, I will write the step for you because the font is really small. View coefficient diagnostic valve test view. Okay, so view of coefficient diagnostic valve test. Okay, so the start, when you write the equation, you may say that, okay, whether beta 2, so C2 equal 0. Okay, so you write down that C2 equal 0. Then click OK. Okay, so you can see this is wall test. Okay, and they can test that whether beta is 0 or not. So you can jump and see probability. Okay, so probability here is less than 0.01. It means we reject H out, right? It means beta 2 is greater than 0. So this means alcohol is necessity commodity. Because this means the higher expenditure, the higher alcohol consumption is very necessity. Right? You have to drink alcohol, something like that. Okay, so I hope you get some general idea how to use program because it's based on theory, but in fact, if you can use program, you do not need to calculate anything, but you have to know how to interpret the printout properly. Like F10 four steps that you do not need to do all four steps, but you have to know how to read probability. Okay. Then R squared, you do not need to compute anything, but you have to know what does it mean, and then what does it mean. This is the thing, the more important thing when you learn econometrics. So let's see the homework. I give you two homeworks today. Oh, it's really long, right? So this is the effect on housing price. Okay, so the housing price depends on plant, nitric oxide, number of rooms, age, distance, access, tax, and PT ratio. So please report briefly. Briefly means you need to report only direction, okay? Because all of them are significant at 1% level. So just explain me only the direction and see whether it makes sense or not. B, by 95% interval estimate. I think we need to skip this one too tired. Okay. Uh, C, test the hypothesis. Okay, you have to do this. 4, test the hypothesis. Okay, you have to do this. So for 4.1, do only A, C, and D. Okay, do not do B. I think it takes time to tired. Okay, so 4.2, 4.2. 4.2 is like computer exercise. So I provide you the cocaine.work file contains 56 observations. Depends on the number. This is the data that price of cocaine drug. Price of cocaine depends on quantity and quality of cocaine and time trend. A, what size would you expect on the coefficients? Okay. B, using the computer. So this is like a solution. Okay. So if you do it correctly, you will get the same printout as my PowerPoint. D, what proportion of variation in cocaine price is explained jointly by variation in quantity, quality, and time. So this type of question is overall F test. So you can use plot F to answer me. D, it is claimed that the greater number of cells, the higher risk of getting caught. Thus, sellers are willing to accept lower price if they can make sales in larger quantities. Set up H now and H1 that would be appropriate to test this hypothesis. Carry out the hypothesis test. So you have to use wall test. The greater number of cells, thus the seller are willing accept a lower price, which means this is quantity, right? So 1, 2, 3, 4. So it means they would like to know beta 2 less than 0 or not. So please think that this one is H now or H1. Okay, and you can use wall test and see the result. Okay, so I think number D, the question is maybe the most difficult out here. So let's try, and then I will give you the solution next week. Okay, so that's all my lesson prepared for today. Do you have any question or do you want to do anything else? Yeah. This one? This one? Mm-hmm. Uh-huh. Okay. Okay. Why? Because it's reject the probability. You can see the probability. Yeah. So because we said H now greater, less than, or equal hello versus beta 2 greater than 0. And the plot said that is go to H1. Okay, let me introduce you again one test. Okay, so I get your question. So we would like to test this one, right? That whether beta 2, so C2 is 0 or not. Okay, so we go to T statistic here. Okay, since we set H now H1 beta 2 greater than 0 versus beta 2 less or equal than 0. Okay, so we can look at the probability. Okay, if this log is greater than 0.05, which means at 95%, which means this is the most confident interval that most of modeler use it. So if greater than 0.05, we can conclude H naught, but it's less or equal than 0.05, we conclude H1, which this case is this case. So we conclude that beta 2 greater than 0. Mhm. Okay, so thank you for your hard work and then see you again next week. I think we have two classes left, so let me see the schedule real quick. This is the chapter 5, so next week, okay, let me check next week. And okay, so next week is 29. So this is chapter 6. Then 6 October, chapter 7. And 13 October, exam. Real quick. Real, really quick. Okay, so the exam start will be the printout. Okay, you will print out, and I will ask you several questions based on those printouts. Uh-huh. Mm-hmm. Uh-huh. So all of you, just you, right? Uh-huh. Okay, so it's like every class I will record the video and you can later learn it via YouTube. Okay, no problem. Okay, so see you next week. Bye bye.